I'm going to start with, oops, I'm going to start with, this is, come over somebody's time. This was page, what page is this? 554 or something? 558. 558? Yeah. And this is page 558, number 2C. Okay, M squared, is this it here? Oh, sorry, my mistake. Sorry. So that's going to be this one here, x squared minus 9x plus 20. How's it? Okay. Number 1 and 2C, that's the one. Yes, okay. Okay, let's just go through this one now. It's just plain x squared. We can do it fast. I'm going to do it slow for right now. I'm just going to place this right here. Okay. Matt, since you are sitting in the front row, okay, you're going to get the first thing. What's the M and what's the A for this question, please?
Oh, M is 20 and A is less than.
Good. Now, if you remember, I'm not on here yet. If you remember when we do this, that again, the M, except for say 9, the M is like the number in front of the x squared. What's the number in front of the x squared? I don't see a number. It's 1, right? This is an invisible 1, is there? Okay. Can somebody please tell me, Aria, what the number is that multiplies 20 and adds to -9, please?
It's -4, -5.
Okay, I'm going to do this with decomp. You can directly go to the answer. I'm going to use decomp just because if you go to the answer, it only works to plain x squared. Okay, right? If it's like 2x squared or 3x squared or 20x squared like our warm-up here, all right, you can't do the quick method. All right, Hannah, can you split it apart, please? Go ahead.
X squared minus 5x minus 4x plus 4.
Right. Now, 5x or 4x, it doesn't matter at all for that. Cecilia, can you do the next step, please?
X bracket X minus 5.
Yeah. Yeah. Okay, now Cecilia, excellent. Okay, what she did there, the brackets have to line up, right? Okay, so let's just say she took out +4, it would be -x plus 5, right? And that wouldn't go, right? It's got to be the same, all right? Cassie, to finish off, what's the final step here, please? Yeah. Now, somebody will say, I was in Mr. Lacey's class, and he said I have to go right from here to here and one step. And you can. Okay, but the problem is you can only do that when? When's the only time you can do that?
There's only 1 in front of you.
Right on. Okay, so I'm just going to ignore that for right now because I want you to practice decomp. That was the purpose of yesterday's lesson, was to practice the splitting apart, okay, right? But when we get into the course and start some fast questions, say we'll do it for you. Was that a question or a stretch? Anybody else have a question? Please be brave. What we did is 9, again, -4, -5, there, then do fraction again. All right? All right, here we go. Emily, we're going to start us through 3b. That was this one right here, 12x squared. That was yours, right? Okay. So 3b, I don't know what page this is on. Okay, perfect. 12x squared plus x minus 1. Now, this looks frightening. It's the very same thing. The difference for these, though, is that there's a number in front of the x squared. All right, Emily, right? Emily, what's the m, please, and what's the a for this one?
The m is -12 and the a is.
Okay, now, if you didn't do a lot of this last year, so I know not everyone did a lot of this last year, okay? Can you please explain, Emily, where you got the -12 from, where the 1 is coming from?
You multiply the 12 by the -1 on the end.
Good.
And then the 1 comes in front of the end.
Right on. Okay, and these are all the same. You'll see on the example we do, just one sec. You'll see on the example we do today, we're going to have enormous numbers. Okay, right, but whether they're small or enormous, you do the same thing. So go ahead.
Can you cross multiply?
Not really. Not on this one. Not really on this one. Okay. Okay, so, Carly, what multiplies to -12 and adds to 1?
3 and 4.
3 and 4? Okay.
One has to be negative.
Good. Which one? Good. Now, if it, sorry, go ahead.
Okay, so I remember yesterday when we like line up and you would do like 1 to 12 and he
Yeah.
was
Yeah. No, okay, no, good question. No, it's because what I was saying is you have to add these together. Because, okay, sorry, I'm so sorry. Because when you're multiplying to get a negative, one side of them has to be negative, right? Like
Right.
a positive comes a negative. But because when you're adding it to one, that means the bigger side is going to be positive. Okay, if this was -1, the bigger side would be negative,
Okay.
right? So like depending on, like it still has to work at the end, right?
Okay, yeah.
So. All right, Thomas, what do I do with the -3 and the 4, please? Go ahead. Yeah. Good. Now, just so the whole class hears this, because I snubbed the front row yesterday, they're getting a double dose of Spider-Man right now. Okay, and then I'll move on to everyone else. Not because I like them more than or less than anyone else. I just want to be fair. So, Thomas, oh, sorry, question, go ahead.
Actually, can I go do that?
Yes, you may. Yes. Keep your phone there. I can't wait till my kids are teenagers. I'm going to be the neatest thing of this. Okay. All right, Thomas, you're back up again because we're doing a double dose of Spider-Man. Can you please do a common factor of 12x squared and -3x? Go ahead. What do they both divide by? 3. Yeah. Good. 3x. What's left inside the bracket? Yeah. Right? -1 puts that. Okay. Now, please note it's not always an x inside the bracket, like not just plain x, right? It's whatever it works out to be. 3 times 4 is 12.
Wait, why is it not negative? Yes, but
Because if, okay, well, it could be, but then like 3x times 4x is positive 12, right?
oh right.
Because this number is not negative, right? So you don't need to do it. In case you want these two to be positive, normally that's what you normally, right? That's what you normally try and do.
You only carry down the negative with the negative
Right.
with the other.
So just think like you're foiling, right? Like 3 times 4 is 12, 3 times -1 is -3, right? That's what's happening. All right, Carly, what's common, please, between 4x and -1?
The negative one or would it just be 1?
Just 1. Now, the reason it has to be 1, if it was -1, that would change this to -4x plus 1, which isn't the same as this.
Okay.
Right, like the brackets have to.
Oh, yeah, I get it.
Okay. All right, Emily, can you be brave, please, and give me the next step?
It would be 3x plus 1.
Yeah.
And then
Now, I'm just going to embarrass some people, not publicly, I won't mention your names, okay? This took me as a math teacher 4 lines to do. If you did this in 1 line on your homework, you're not doing your homework. It's impossible to do this question in 1 step on your homework, okay? And there are a few people that tried to do it. If you did the quick version on this, that's fine. Okay, right, but it takes a little bit of work to be shown. 1, 2. Go ahead, Taylor.
You don't care how we do the question.
No. Yeah, right. If you like did it a little differently, right? If you did like 4 plus 4 minus 3, that's fine as long as the final answer is good. And the same thing, it could have been 4x minus 1 could have been on the left, and 3x plus 1 on the right. Yeah, go ahead.
I just wondering if we could do 1C. Like, I know it's probably simple, but
Yeah. 28x squared, that one?
no, the one that's like.
Oh, 3, oh yes, yes. Yeah, okay, no problem. 3m squared. All right. Cassidy, I clearly want a difference of squares this, right? No. What do we do for this one? Okay, let's not please. Cassidy, what do I do for this one instead of difference of squares? Yeah, good. Okay, so what we're going to do is we're going to look at the numbers, the m's and the n's, and try and take out a common factor for all of them. Okay, so Cassidy, you're not done yet. What is common between these two for numbers? Yeah, good. What for m's? Good, and what for n's? If you take a look, you can divide both those by 3, you can divide both those by m squared, and you can divide both those by n cubed. All right, Cecilia, what's left inside the brackets now? Now, this is what scares people, okay? But just think about it, right? 3 times 1 is 3. M squared times 1 is m squared. M cubed times 1 is m cubed. 3 times negative 3 is negative 9. M squared times m is m cubed. And n cubed times n is n to the 4th. Right, so just what you're dividing everything by. Yes? We're good? Okay? All right. Yes? I talked to your dad last night, by the way. Did he tell you? Number 5. Okay, now this one, I don't know why I assigned this every year. I shouldn't, okay, because it's worded very poorly. This is number 5 on page 558, okay? It says the population of a city is P is equal to 0.5 T squared plus 10T plus 200, where P is population in thousands, and T equals 0 means 2,000. Okay, so before we've even begun this question, they've already made it difficult in 2 ways. T does not actually mean 0, it does not actually mean, it means 2,000, okay? And P is a population in 1,000. Can somebody please tell me, for anybody here, what the population in thousands means? What does that mean?
Like if it's like 1, it's not 1 person, it's 1,000.
Right on, okay? So if P was very good. So if P was equal to 1, P would really be 1,000. Now the reason we need that, because the question says, when is the population 350,000? And that's why I don't like this question. Okay. And that's why I don't like this thing, because they're being tricky here. So what this means is P equals 350. Okay, I'm going to show you how to solve this one right now. 350 equals 0.5 T squared plus 10T plus 200. Are we okay on that to begin with? All right. Yeah. When you have a quadratic that you wish to solve, okay, what's the very first thing you have to do?
You have to make it equal 0.
Awesome. Okay, so how do you make this one equal 0?
You move the 350 over to the right side, so it would be minus 20.
Good, very good. Now, we can use quadratic formula. We didn't actually talk about the second way to solve, but I'm going to solve this one by factoring, I think. Okay? I'm going to try to if I can. I don't know if it does actually factor. Does this end up with nice answers or not? Did it answer like T equals 13 or something, or was it like 13.294392? 10? We'll do it by factoring then. Okay? So, the thing is that I don't like with this question is that 0.5. Can somebody be brave and suggest me how I can get rid of that 0.5? Go ahead.
Multiply the whole thing by 2.
Good. Okay. You don't have to do this. You can quadratic formula will do this, but I want to show off my factoring skills. You can multiply by 10 if you want to get rid of the slide the decimals one and multiply everything by 2. Now, how can I get away with this? Like, why does that not change the question? Why is that okay?
Isn't it 2022?
Whoa, goodness me, you guys are right on top of things. Yes, that would have caused me difficulty when I was looking for the MBA. All right. Why is it okay to do that? Like, why does that not change my question? Go ahead. Oh, freeze, that's okay. Yes, go ahead.
Because the 0 on the other side doesn't change as well.
Yeah, although it didn't look like it, I times this by 2 as well, right?
Yeah.
Okay, so 2 times 0 is still 0. Okay, I'm going to factor this one. Okay, now to show you how to solve this by factor. If you use quadratic formula, it's not wrong. Sorry, go ahead.
Where did my slide go?
Oh, what I did was because I don't like decimals to factor, it's impossible for me to do, so I just got rid of it. What I did was I times this by 2, so 0.5 times 2 is equal to 1, right? And then 10 times 2 is 20, negative 150. That's an optional step, but I don't like decimals, so I'm going to get rid of that. Yeah, if it's like 0.5, it'd be 2, right? But like if it was like 0.1, you'd probably times it by 10, right? Okay, if it was like 0.12, you'd probably times by 100, right? Because you're shifting it. Do you remember science? They talk about that in science class, right? They talk about that, shifting digits and all that stuff. I think they do, right? So the same idea as that is all I did there. Yeah.
Because 0.5 is the same thing as 1. So
Yeah.
would it work if we used fraction with that?
Yeah, but yes, but it's much easier with just equal to 1. Yes, it could work. Yes, and I could do this. I'm a math teacher. I could do it like this too, but I'm not going to today. Okay. All right. So let's do the M and the A here right now. Matt, I think we're up to you. What's the M and what's the A for this question? Multiply to what? Add to what?
Multiplying is negative 30 and adding 20.
Okay. Can anyone, Matt or anyone else, tell me what those two numbers are for 300? Matt, go.
Negative 10 and 30.
Negative 10 and 30. Now, Matt, you're amazing. How did you come up with that in your head? He just did it. He's amazing. He's amazing. That's it. The thing that I'm thinking with this, I see zeros everywhere, so I'm hoping there's a 10 in there. That's what I'm assuming, right? Because everything's got a 0, so that's what I'm thinking. All right. Can somebody please, actually we're up to, Robert, I believe we're up to you. If I'm using negative 10 and 30, what do I do with that?
Change them for 20, so it's squared.
Yeah. Yeah.
Oh, t minus 10 t.
Yeah.
And plus 30 t.
Yeah.
Minus 30.
Okay. I'll go to the next slide here in a sec. All right. Molly, what do you do next, please?
You have to take out the multiply, so t and 30.
Good. T comes out there, and that turns to 2 minus 10. Plus 30, and that's t minus 10. Okay, we're almost done. Noah, can you finish factoring, please?
Bring t plus 30 over
Okay, now I'm going to take a little pause here. If you did this with quadratic formula, I would like you to write that line down on your page right now because I want to talk about something new, okay? So even if you got the right answer with quad formula, I just want to remind you something from last year. So I didn't talk about this yesterday and I forgot, and I feel bad about it. So it's too flustered by the factoring here. One of the reasons you factor is to find roots, okay? If I have two things multiplied together to get 0, what does one of the numbers have to be? If I say 18 billion times what equals 0? 0, okay? If I say negative 3.428569,894, 0, good, okay? So the point that I'm trying to make for that is, if I have two numbers here multiplied, please. If I have two things here multiplied to get 0, okay, that would be t plus 30 or t minus 10 equals 0. Is that looking familiar for most people from last year doing the roots there? Okay, so if it equals 0, you can solve that. Okay, right, go ahead.
Wait, never mind, sorry.
You good? Okay.
I was thinking about, wait, what's this, a quadratic?
Yeah, quadratic formula we did, was it yesterday? I can't
Wait,
remember.
I
Mine's
thought like if you're dropping the 30 and then the 10 are the.
No, it's not. It's negative though, right?
Those are just like zeros, right?
Right on.
No, I know that, but like I thought. Yeah, like you switched around and those are okay.
So, as far as the answer to this question, Rachel, what does t equals negative 30 mean, and what does t equal 10 mean? Good, but at what year are those going to be? Oh, 20 IO. Somebody help her. She's almost there. She missed the last step. Chase on, go ahead. What else? 1970, right? So therefore, the two populations, will be 350,000 in 2000 plus 10 equals 2010, and 2000 minus 30. This is one where the negatives actually work, okay? So this is probably a town that started off enormous, and then maybe, I don't know, they closed some factories or something, and they lost people, and then weren't able to get back to town, whatever, okay? Are we sort of okay? I want to talk a little about this today. We're going to do some completing the square as well too. All right, so I'm going to hit pause in the video. If you're not done those two questions, get them done. Number B, if you did with quad formula, can you try it like this? So I'm going to do the example like this. Okay, try it by factoring if you do it by quad formula. It's okay to do it by quad formula, okay, but I'm going to try it. Gosh, 20 minutes.